Hello and welcome to my student. Today's lectures we have see that the topic carbonyl compounds. In these topics, now we have see the aldehyde and ketones. Aldehyde already we have complete. Now we have see the ketones. Ketones, they will have this type of functional group which is present. So these molecules of the ketones given the IUPAC name as per their rules. So this number of rules we have seen in last years in FRDC. Now we have seen how will you given the IUPAC name for those molecules. For example, the chain in the chain of this ketonic of the alkane, this E of the alkanes can replace by the O and E, right? Second rules which are very important to given the name, the number they will indicate the lowest priority to the carbonyl compounds or carbonyl group, right? Now we have seen some examples. We have given the IUPAC nomenclatures for those molecules, like those ketonic molecules, the numbering is given as like 1, 2 and 3. So name is given 2, how many carbons? 3 carbons, so 2 propanone, N-O-N-E. So E replaced by O-N-E, 2 propanone. Now we have seen other examples like so numbering is start like 1, 2, 3, 4 and then 5. So this second positions it will have one of these carbonyl group. So name is given as like the 2-pentanone. Now we have seen other examples of these ketones. If the substituent is present in the chain of ketonic group, like the name is start 1, 2, 3, 4 and 5. But this third positions it will have one of these methyl group. So name is given as like the 3-methyl 2-pentanone or 3-methyl penta, right? Pentane. So this E replaced by O and E. So pent 2 O and E 2 1. Right? So other examples also we have see given the IUPAC name as the common name for aromatic systems as like those molecules having the benzene being attached to acetyl group, name is the acetophenone. Now similarly other examples Also, we have CH here. This methyl group can replace by other phenyl group. Then name of the ketone is benzophenone. Benzophenone. Other examples like quinone systems. So those ketones are named as the hydroquinone. Hydroquinone. If it is containing the two carbonyl group which is present, then given the name for the IUPAC of those molecules, the word are used as the di, tri, etc. Right? So these type of examples now we have seen here, like the CH3, C double bond O, CH2, C double bond O, CH3. So number is given as like 1, 2, 3, 4 and then 5. So second and fourth position having the carbonyl group like is here. It is also carbonyl group. So name is given as like the name of parent alkane is pentane. Pentane. And therefore this pentane, this E replaced by O and E, but pent the 2,4 diene, right? Pent 2,4 diene. If the molecule is containing both, like the aldehyde as well as ketonic group is present, that times the molecule's name is given as like differently, like CH3, C double bond O, CH2, C double bond O, H. Means those molecules which contain both functional group. This is a ketonic as well as aldehyde group, right? So 1, 2, 3 and the 4. So now name for those molecules as given. Aldehyde is a parent alkanes, and then the ketonic groups, the words are used as a oxo, and therefore for those molecules the given name as the 3-oxo, and then name of parent alkane is butanol. 3-oxo butanol. Next examples we have seen as like the both functional group which is present, like aldehyde and ketones, the ketonic group, the words are used as oxo, and then name of parent alkanes as per IUPAC. Next examples now we have seen as like zigzag structures. So name is given as like this 1, 2, 3, 4, 5 and then 6. So 2, 5 hexane, but this E replaced by E, but 2 times, so hex diene, or another type is hexane. So E replaced by hex 2, 5 diene. Other examples, it having the both functional group aldehyde and ketones. So name aldehyde is the parent alkenes. So number start like from aldehyde. So 1, 2, 3, 4, 5 and then 6. So name was given for those molecules as like this 5 oxo, and then name of parent alkane is 5 oxo hexanal. Hexanal. So such types of naming was given for the ketonic and aldehyde group as per IUPAC nomenclature. Then next points, now we have discussed the reactivity of carbonyl compounds. Reactivity of carbonyl compounds. Reactivity of carbonyl compounds. You know that carbonyl compounds, it having the two different atoms. One is the carbons, other is the oxygens. So oxygen is more electronegative than carbons. That is the polarity of oxygen and carbons which will differ, and therefore those molecules will show the polar. But now we have seen the structures for those carbonyl compounds in hybridized structures. Like both carbon and oxygens having sp2 orbitals, right? sp2 orbitals. So sp2 orbitals of the carbons to form this sp2 orbitals with oxygens to get C and oxygen bonds. This is C and oxygen bonds, and other two sp2 orbitals of the carbons which forms the new bonds with the hydrogens or the two alkyl group or the aryl groups, and oxygens, the sp2 orbitals which can laterally overlap with the carbons and to form the pi bonds, and other two sp2 orbitals of the oxygens which is present the lone pair of electrons, and therefore these carbon and oxygens having the sp2 orbitals which are formed 1 sigma bonds and the 1 pi bonds by the lateral overlap, and therefore these carbon and oxygens can overlapping and to form the single bonds with carbon and oxygen at a sigma bonds and lateral overlap as the pi bonds. But some of the points also which are very important to discuss the reactivity of carbonyl compounds. So first points which are very important like their electronegativity. Electronegativity. In periodic tables we have seen carbon and oxygens. Oxygen is more electronegative than carbons, and so this difference of the electronegativities, the carbon and oxygens, they show the polar bonds. Second point, which shows the resonating structures. We show resonance structures. For those resonance structures of carbonyl carbonyl carbons, it resonance structures after given the electrons to oxygens and to form this positive charge on these carbons. So this formation of positive charge is here on these carbons is a tertiary carbocation, and those tertiary carbocations which are more stable. And these extra electrons also present on the oxygen atoms. So the disperse of positive charge or disperse of those charge, like a positive charge on carbons and negative charge on oxygens, which are the hybrid structures which is more stable. Third point, now we have discussed the extra electrons present on oxygens, like in the form of this lone pair of electrons, and therefore the carbons in aldehyde and ketones are electron deficient carbons, and hence aldehyde and ketones undergo the nucleophilic addition reaction. Nucleophilic addition reaction. Nucleophilic addition reaction to the carbonyl carbon. So these 3 points which are very important to show these carbonyl carbons of these aldehyde and ketones which are more reactive towards electrophilic addition reaction. But this type of reactivity can also enhance by some of these groups or some of these factors. First factors, now we have seen size of substituent. Size of substituent. And second factors which are important to the electronic effect. Electronic effect. Now first factor we have seen the size of substituent is attached to this carbonyl carbon. If this is carbonyl carbons is attached to the substituents as like it is CH2 CH3 are here and CH3, that is the ketonic, and this is a aldehydes. If the substituents on this carbonyl carbon is large or bulky substituent is attached, that times the reactivity of the carbonyl carbon will be decreases, because those substituents on the carbonyl carbon can get hindered, because those substituents can hinder, therefore the nucleophilic additions which can be prohibited. It means the nucleophilic addition cannot take place easily, but hinder the addition reaction to the carbonyl carbon, and therefore as the size of the substituents on this carbonyl carbon increases, that times the reactivity of carbonyl carbon decreases. This is the first point. Second point we have seen as the alkyl group like a methyl group act as an electron donating resonance effect, and therefore we have seen this methyl group can donate the electrons to the carbonyl carbons. These parts or this ethyl group, it is also act as electron donating resonance effect, and hence electron density at this carbonyl carbon they will be more or increases, and hence the nucleophilic addition reaction does not take place at these carbons or decrease the reactivity of carbonyl carbon by the plus R effect or the plus I effect of these substituents. Electron withdrawing group, they will increase the reactivity of carbonyl carbon because if which is present as the chloro or this nitro, this electron withdrawing group as withdraw the electrons from these carbonyl carbons, and these carbonyl carbons which are more and more electron deficient, and hence the nucleophilic addition reaction is more feasible by electron withdrawing resonance effect. And therefore in aldehydes only one alkyl group is given the electron donating resonance effect to the carbonyl carbons, but other side is a small size of the hydrogen are there, so these hydrogens which is act as does not use the more plus R effect, but this methyl group it gives the more electrons to this carbonyl carbon. But in ketones, the two alkyl group they will given the electron to these carbonyl carbons, therefore reactivity will be decreases. And in aldehyde only one alkyl group given the electrons to these carbonyl carbons, and hence as compared to ketones and aldehydes, the aldehydes are more reactive than ketones, or ketones are less less reactive than the aldehyde. Now we have seen order of reactivity, like formaldehyde which are more reactive than acetaldehyde, and acetaldehyde which is more reactive than ketone, like dimethyl ketone. So this is a order for the reactivity of the carbonyl carbon. Now we have seen some reactions of aldehyde and ketones. First method for the preparation of the aldehyde and ketone, right? So first reaction now we have seen to prepare the aldehyde from the alcohols, right, by using PCC, pyridinium chlorochromate, PCC, pyridinium chlorochromate. Those reagents also the name as the Corey's reagents. Corey's, the name of the scientist, Corey's, C-O-R-E-Y, Corey's Sucks reagent. Corey's Sucks reagents. Those reagents which are helpful to convert primary alcohol to aldehyde stage. Therefore, the reaction can stop only and only at aldehyde stage by using these alcohols. Now, firstly we have seen the preparation for those reagents. The chromium trioxide can treat with this HCl, concentrated HCl, and to get the chlorochromic acid, and this chlorochromic acid can treat with pyridine and to get the complex of pyridinium chlorochromate, to get complex of pyridinium chlorochromate. Pyridinium chlorochromate, right? So name is a PCC, pyridinium chlorochromate. Firstly, chromium trioxides can treat with concentrated HCl and to get chlorochromic acids. Those chlorochromic acid can treat with pyridine and to get the reagents at PCC, pyridinium chlorochromate. And those reagents which are helpful to prepare aldehyde as well as these ketones. Now we have seen this. This benzyl alcohol can treat with PCC, pyridinium chlorochromate, and those benzyl alcohol they can be converted into benzaldehyde. Convert into the benzaldehyde CH2Cl2. This is used as a solvent for the reaction dichloromethane, or in short DCM, dichloromethane as a solvent. Second reactions now also we have seen like this. This is ethyl alcohols can treat with PCC in DCM, then it convert into aldehyde CH3C=OH. One of the main roles for those PCC reagent is reaction is stopped only and only at aldehyde stage. It means that those product which is not converted into acid. It is very important. Secondly, next we have seen others. These secondary alcohols are treated with PCC in DCM, then convert into ketone. Last time we have seen that this primary alcohol on oxidation to give aldehyde and secondary alcohols which on oxidation with oxidizing agent to convert ketone. Secondary alcohols, ketones, right? Primary alcohol, oxidation, it gives aldehyde. Secondary alcohols, oxidation, it gives the ketones, right? Therefore this is secondary alcohol, so it gives acetophenone. It gives acetophenone. Now see some other examples. Also it converts into corresponding aldehyde or ketones. PCC So this is a secondary alcohol. Secondary alcohol gives ketone like this. CH3, CH2, CH2, C double bond O, CH3. Similarly, those convert corresponding ketones. Right. Third, methyl alcohols. This methyl alcohol can treat with PCC, pyridinium chlorochromate. This convert into formaldehydes like C double bond O, then H, formaldehyde.